This is what cot looks like with a caveat. It's actually all wrong. This is actually all wrong. I wonder if anyone can spot it. I sort of fenced myself in. I didn't have to do this, but I thought I could rub it all off and start again. But anyhow, let me tell you what's right about it first. The shape. The shape is right. The shape is right. It's just like tan, except it's being reversed. Okay, which shouldn't surprise you because it's the reciprocal of tan. The asymptotes, x equals 0 degrees, x equals 180 degrees, x equals 360 degrees, the asymptotes are also right. There's something else that's wrong. Can anyone spot it? What do you mean, Raph?
Well, where the two graphs, where sine and cos graphs meet, it should be 1.
Okay, very good. I'm not sure if you caught that. It's quite a subtle point, and you might see now why I said I didn't have to do this. To illustrate how cot works, I drew in the numerator and the denominator. So I'm doing, if you want to think about it this way, with my two graphical components on there, I'm doing, other way, the blue graph divided by the green graph. That helps me see, okay, where are the asymptotes? It's where the green graph, the denominator, it's where that's 0, okay? How are the other things behaving? Well, I can see how the blue and green graphs are interacting with regard to signs. But that immediately tells you, right? For instance, there are easy parts like here. Here, the numerator, blue, is 0. So I don't care what the denominator is, so long as it's not 0, which it's not. So that's why it goes to 0 at 90 degrees. However, the other glaring point is right here. Okay? Think about that point. That's where cos is equal to sine. So you actually know what that angle should be, right?
So it should intersect.
So that should be 45 degrees. And at that point, cos of 45 is 1 over root 2. Sine of 45 is 1 over root 2. Okay? So the numerator and the denominator are the same. And when you divide two numbers that are the same, you shouldn't get this.
It should be
You should get 1. Right? Which I've already put in as up here because that's where cos and sine are. Okay? You might be able to see why I decided to draw it through here rather than up there. Because if I had drawn it up there, my scale would have been, you wouldn't be able to see the curvature of cot properly, so I made an executive decision, okay? But if you were, and occasionally this happens, that you get asked to draw two graphs on the same set of axes, you got to make sure that their scale is consistent with each other, which at the moment they're not. But that's what it looks like. One last question. Here's tan, right? Here's tan. You'll notice, like we know what tan looks like. So why did I not just draw tan and say, well, it's equal to 1 on tan? Can anyone see the reason? Cot is more than just 1 on tan, yeah. So notice how tan has asymptotes, right? So if I take the reciprocal of, say, that's 90 degrees there, right? So what would happen here when I take the reciprocal? What would happen on this graph?
just sub 1 over 0 and 0 over 1.
Think again. Look, it's an asymptote. It's a vertical asymptote. What does it mean about a function when it has a vertical asymptote?
Oh, it has to change because all the ones that had a denominator of 0, the denominator is no longer 0, it becomes a numerator.
Aha, okay. So here, a denominator 0 means the graph doesn't exist. So if I were to graph the reciprocal of this function, that when I go down to 90 degrees, I should have a discontinuity. Can you see that? Because like, what's the reciprocal of something which doesn't exist? It doesn't exist, so it can't exist here, right? So you'd get this shape.
So that's wrong because it doesn't.
Okay, but it does exist because cot is more than just 1 on tan, it's cos on sine, which is perfectly defined at 90 degrees, it's 0, okay? So if you're wondering why, like why did I go through more graphs when I already know what it should look like and take its reciprocal, it's to avoid this, right? Which would be just the same as if I asked you to graph this, right? You'd say, yeah, fine, I would just graph this, wouldn't I? It's a no, there's a difference. This guy looks like this. Just a plain old linear function, right? The difference is that this guy has a hole in the middle because he can't equal 0. You see that? Very, very tiny difference, right? But it's a difference nonetheless.